Welcome to the Mitchell Center for Sustainability Solutions and our Sustainability Talk series. My name is David Hart. I'm the director here. It's great to have you with us. Introducing today's speakers, it's a wonderful team. One team member, I realized I'll let them figure out who it was, reached out to me in about, I think 11 years ago, and started a conversation that led to a lot of great work here. And this, I think, is connected to that in ways. I'll let them tell you that story if they choose to. But four members of the team are here today. And I'll just say briefly, Reed Miller from Civil and Environmental Engineering, as well as the Advanced Structures and Composites Center, John Belding from the Advanced Manufacturing Center, and John, thanks for the co-sponsorship. Jean MacRae, also from Civil and Environmental Engineering, someone we've worked with for a long, long time, and Cindy Isenhour from Anthropology and the Climate Change Institute. So you could go, I guess you can read a little bit about their backgrounds on the information today. What I think is really innovative about this team's work is the way they bring together so many different kinds of skills, ways of knowing, ways of thinking, systems thinking, life cycle analysis, manufacturing, circular economies, industrial ecology, and you'll see why that's so important for this work. They also build really strong partnerships, which is a key to everything we do here, with partners in what I call the real world. I know there are people who think universities are the real world. I have a beer about that, and I may do that right after this. In any case, partnerships with the Maine Manufacturers Association of Maine, Maine Resource Recovery Association, a long-term partnership there with the Governor's Office of Policy Innovation in the Future, where we've been working for as long as it was created, from day one almost. One of the problems on which they're focused is what can be done to reduce the 250,000 tons of special waste that go to Maine landfills every year. And that's just one example of some really complex problems associated with materials management, about which we need teams like this working in the kinds of partnerships they're helping to build. Please join me in welcoming them today to the Mitchell Center.
Closing the loop. So here today we're going to be talking about closing the loop, which is our way of thinking about opportunities for industrial circular economy exchanges in Maine. So the goal really is to figure out ways to circularize our more or less linear material system. I'm so happy to be working with these folks. Cindy is someone who's been studying in anthropology, but really just how to make our societies better and more sustainable. I've been working on materials management for many years now. Reed joined us not too long ago, and he's been awesome at helping us analyze how to figure out if things are sustainable. And John has been working at the UMaine for a long time, creating these partnerships with industries and folks who make things. And it has been really great to start working with him on this project. So our agenda today is to talk a little bit about materials, how to circularize the system. We're going to look at some case studies in Maine and globally, and then we're going to look forward toward what to do next. Like how do we actually make the system better? So I'm going to start with the material system, and I'm starting really technical here. Stuff in nature cycles. And there's a reason that it has to cycle. If it didn't cycle, we would basically be living on a dead planet with a bunch of trilobite bones on it and nothing else happening. It's really important and vital for carbon dioxide in the atmosphere, which gets taken up through the fantastic process of photosynthesis, which takes energy from the sun and sticks it in carbon-carbon bonds. Those carbon-carbon bonds make up the organic matter that is the base of all of our food chains and produces plant matter. Plants, because they hold all of that organic matter, are great food for other things. So bunnies can eat them and make more bunny matter, which is an awesome thing to do if you're a bunny. The bunny is actually gonna take some of the plant matter and turn it into bunny, and the rest of it is gonna be broken down to carbon dioxide through the process of respiration. So that's where the carbon dioxide comes back to the atmosphere. And that fuels the whole process of making more bunny and also letting bunnies hop around and their noses and do all the cute things that they do. Anything that's leftover bunny when it sadly dies, or leftover plant material also gets broken down by the detritivore food web, which includes worms and fungi and all the really great things that we underappreciate, who then make more carbon dioxide to keep us going. So go team. Stuff cycles. And our stuff really needs to cycle too, because not just carbon, but everything else on the planet is present in finite supplies. So if we need it and we want to use it in our industrial or human systems, we need to make sure that the things cycle. This is just a graph showing the x-axis down here is the time from 1900 to more or less present day. And what it's showing is the increase in materials use over time. So it's going up or about, looks kind of linear at this point up until about 1950, and then you start to use a whole bunch more stuff. The two things to notice, so that who we part is where we're accelerating the use of materials. But down here, if you look at what it's made of, this green bar is biomass, so carbon-based stuff that would circle in that cycle that I mentioned. The blue bar here is fossil energy carriers. So that means any of the fossil fuels. So it could be the materials that are built out of those fossil fuels, or just us using the fuels as sources of energy. And the brownish one is construction minerals that come also from the environment. And there's one in between. This guy here is ores and industrial minerals. So those would be things like metals. So what's really changed is the total amount and the composition of the materials that we're taking from the environment. So if you look at these two pictures, it sort of illustrates it in a more human way. So the one on the left is some American people in around 1900, and they're standing in front of their pretty small house with some of their stuff, which includes an axe, a metal handle. All the clothes that they're wearing would be made out of natural fibers, and their house is made primarily out of wood. There's a little bit of glass here. There's probably a potbelly stove on the inside, so a little bit of metal, but really they're not consuming a whole lot of stuff. And most of it is pretty readily recyclable and easy to separate from each other. But if you look at the picture on the right, so here's our American family, and here's their big old house, and here's their stuff. And there's a lot of it. B, it's complicated stuff, right? So this is all metal, but with some wiring inside. So there's going to be plastic on that. There's insulation. There's all this other stuff. There's a lot of plastic you can see in this picture, right? And then back here, there's some wood and some paper, lots of different things. These in particular are really complicated. Lots of different materials all sort of jammed together in one product. So people and their stuff changed over time. And this is just actually showing from the year 2000 until 2022. And you can see that global total materials consumption per capita has gone from a little over 9 tons per person per year to a little over 12 tons per person per year. So that's almost 25% higher. So it shows that we are consuming way more stuff. It's not all happening right here, and it's not all happening at the same rate everywhere, but it is showing that there's this big increase in consumption overall. So what's the problem with that? Awesome, we're all getting rich and everything would be super duper if we were maintaining a circular system and actually being able to reuse those materials that we're taking from the environment. But you can see here on the left, this is our linear material system. This is resource extraction coming from mining. A lot of waste comes out of this process. A lot of energy goes into it, a lot of water goes into it, and a lot of labor goes into it. Lots of stuff left behind. The good bits go into manufacturing where we make our stuff. More energy, water, and labor goes into that. More pollution comes out. At the next stage, we have transportation. Things are being moved to the final user. And then when we're done with our stuff, we have this disposal system where more or less everything gets piled up and buried together. So that's a problem. How come we have a linear system when we know we need to circularize it? Like this isn't brand new, this idea of needing to circularize it. And one of the big reasons is that products aren't made where they're used. So this map is showing where trade actually happens and things move from the US to Europe and then back again, and Canada to the US and from China to the US. All these lines are showing where materials are moving. And that means that we're not making it where we're using it. And then the other part of it is when we're done using it, we discard it where we are. So the materials that are being discarded aren't actually where they're needed to make more stuff. So this is our problem, the main reason why we have this linear system, and the reason why we need to think really carefully about how to recover and reuse material. I'm going to turn it over to my great colleague and fall over.
Okay, thanks, Jean. So I'll talk a little bit about circularity, and I have a feeling that by this point in time, most of you have just in the room. How many of you have seen this diagram before or something like it? Yeah, so this is the circular economy. It's not a new idea. In fact, it's kind of an old idea, going back to kind of the advent of industrial ecology and Stahel and a lot of folks who talked about cradle to cradle design. But this is what we call the butterfly diagram that was made popular by the Ellen MacArthur Foundation. And it's become kind of an international phenomenon, right? We hear a lot of talk now about the circular economy. And you can see on the diagram we have on the green side, kind of the biomaterial, organic side, and then on the left, the material side. And the basic foundation of the idea of the circular economy as it's been popularized by Ellen MacArthur is that we have three core tenets, right? We want to try to design systems that eliminate waste and pollution from the very design. We want to circulate materials, and we want to try to regenerate nature. Sounds great. We can talk later, if you'd like, about some critiques of this diagram. There are plenty of them out there. But for now, I'll just point, if you look at the blue side, it's interesting, right? We see the materials coming in a linear system from the top, right? And they come through primary producers, product manufacturers and service providers down to consumers. And here we see consumers circling goods back up into the chain, right? Instead of them going into disposal or incineration, they get cycled back, which makes good sense, right? I'll come back to this in just a second. There now, with the popularization of circular economy as a concept and an aspirational goal, we've seen lots and lots of reports that have attempted to model like what would be the likely benefits of achieving full circularity. And here are just a few reports. One report, International Labor Organization and Circular Economy, projected 2 to 8 million new jobs worldwide, right? If we can circularize systems, that has to do with reverse logistics and reprocessing. A 39% reduction in global greenhouse gases, which really makes up a huge part of that ambition gap that we're currently facing. So it's a lot of potential there. 1 trillion annually in materials and waste savings alone, right? This is the money that we pay to bury things in the ground, to incinerate it, to truck it, and also on sourcing, right? If we pull that down, so those are some global reports. I'd like to pull that down and think about the potential here in Maine. And I think when people think about circularity, we think automatically about kind of material savings, right? Nobody likes waste. No one's going to tell us that they like waste, right? And businesses don't want to have waste, right? If you talk to a business owner and they have a lot of waste product, they don't want to have that, right? It's expensive to dispose of. It's also wasteful, right? People who pay for inputs into their processes don't want to just see it go away. There are also significant environmental benefits, and that has to do when we get circularity with displacing demand up the product chain, right? So this idea that not only are we recycling materials back into productive systems, but we can, when we do that, we can also circumvent the demand for new virgin extraction and all that goes into that as well. Some things that people don't think as much about have to do with like regional resilience, economic development. I didn't put it in here, I have no idea why, but environmental justice and social capital. So I just want to talk for just a second about each of those. Well, we are all reading the news every day, right? And this idea of tariffs, right? Or barriers to trade. We also just all went through COVID when we had serious supply chain disruptions, right? And so there are some vulnerabilities associated with supply chains that are long and easy to disrupt. And so when we think about circularizing our systems in regional areas, maybe even rural Maine, we can think about building resilience in the face of supply chain disruption. Also building local employment, right? Creating jobs for people in terms of reverse logistics and bringing materials back. And then finally, something that people don't often think about is that when we get alternative systems of procurement, that builds social networks when they're local. And so we had a former student here at UMaine who did really great work on reuse in Maine and found that one of the benefits that's maybe really discounted is the amount of social capital it builds in communities to work together and to figure out how to have better materials management systems. So I want to come back to the circular butterfly diagram from the Ellen MacArthur Foundation. And one of the things that our project is working to do is to help to identify opportunities for these closing loops and also slowing them down to reach all those benefits. But one thing, and again, there are lots of critiques of this diagram. Happy to talk more about that later. But one of the things that we identified is it doesn't really do a good job of showing where there might be opportunities, for example, to prevent waste before we get all the way down the linear supply chain, right? So if we have parts manufacturers who have waste materials that they don't need anymore and would only be disposing of them, why not see if there are collaborators locally or regionally who could use those waste materials and integrate them into their own production process? So we've created our own little loops here. And that's the idea with this project. Before I turn it over to my colleague Reed, I did just want to mention one thing. So when we think about, I'm going to go back to that diagram for just a second. When we think about all the activities here, right, we can think about extending product lifetimes by using them longer as consumers. We can think about identifying opportunities for repairing items to keep them around longer to circumvent new demand. We can think about remanufacturing, right? So taking old parts and remanufacturing them into new products. So there are a lot of different, and there's also recycling, right? But one thing I wanted to make sure to point out is when we think about circular economy, a lot of people automatically just go to recycling, right? Oh yes, we're just going to take these materials back and we're going to recycle them into new things. That's great, and we should absolutely be doing that more than landfilling or incineration. But recycling does take energy, right? It takes it takes trucking, it takes processing, it takes energy inputs to recycle into new things. What this project that we're going to be working on in Closing the Loop is really focused on the reuse of industrial waste products, right? So reintegrating them into that system without a whole lot of additional inputs. And so I just wanted to show you one graphic. This is not exactly equivalent to some of the work we'll be doing, but this is looking at the reuse versus recycling of 50 tons of different types of packaging. So we can, in the top bars, steel, glass packaging, polypropylene, or what is PET? Polyethylene, thank you. So we can, and what our metric here is equivalent number of vehicles annual emissions. So when you see these numbers, so 592 under reuse for PET, that would be the equivalent savings of taking 592 cars off the road for a year in greenhouse gas emissions equivalents. So it's you can see here that if we can reuse things at 50 cycles. So let's say you have primary packaging material that comes into your facility, and you can use that 50 times versus reusing it 25 times, you're gonna see these improvements just over recycling, right? This is not compared to landfilling or incineration. This is just over recycling, right? So huge benefits compared to recycling. That's why we're really focusing on materials exchanges and industrial symbiosis. So with that, I'm going to turn it over to my colleague Reed, who's going to tell you, get into a little more finer detail with what we're actually doing. Thanks, Reed.
Hi, folks. As you said, my name's Reed Miller. I'm a assistant professor in environmental engineering and the Composites Center. It's been a real privilege since I've been here to get to work across the disciplines, get out of our silos with Cindy and Jean's down the hall from me, but Cindy and John and others. So I think I agree with David that this is kind of a unique aspect of Maine. So while you're here and studying, or take advantage of that and get out of your department. Anyhow, so my field is also, where'd that mouse go? My field is environmental engineering, but I also am an industrial ecologist, and that field is based on this idea that we have a lot to learn from nature, as Jean was talking about, and we're trying to think from a systems perspective, how can we recreate our production and consumption systems in ways that are analogous to and better for the natural environment. So when we think about symbiosis that you probably learned in biology class and mutualism, here's an example. Okay, the flower needs to get pollinated, a bee needs nectar, works together. So can we try to translate that to industrial ecosystems? You've got a factory that's making byproducts that it doesn't quite need, it's generating waste, but hey, there's another factory that could use that. Wow, your process generates excess steam or energy. Well, this process down the street could actually use that steam instead of just venting it. So the point here is to be strategic about that, look for those opportunities and take advantage of that. So just a snapshot here, circa 2018, of some documented industrial symbiosis studies around the world. See, we are a little sparse here in the US, but we have a lot that we can learn from our colleagues and other existing demonstrations across Europe, across Asia especially. And there's some missing from this, so South America as well. So I want to start to talk with a couple global cases before I pass it over to John to talk about what's going on in Maine. This is the classic case that if you've heard about industrial symbiosis, someone's probably said, oh, like column board. So this is in Denmark. They got kickstarted around 1972. There's 17 companies here that are situated near each other, and they're exchanging a lot of flows. So just as I mentioned, one might be creating excess steam, so they pipe it over there. One has one kind of waste. So they've got this categorized where dark blue is water, the yellow is energy, and the green is materials. So here's some of what they've come up with over this time, building trust, building partnerships, strategically trying to figure out what all companies might be generating that could be used in others. So it's been a gradual, intentional process that has been extremely successful, and folks have traveled from all over the world to see how they do it and try and replicate it where they are. Here's another. This is Ulsan in South Korea. So just to give you a sense, we've got kind of a massive area here. A lot of really high-tech production is taking place. And there are some examples, for instance, where CO2 that's coming out of a zinc manufacturer is piped over to a paper manufacturer, and they're reducing the emissions, reducing raw materials and waste. So the blue is before and the pink is what happens after. So previously they were just emitting the CO2 and now they found the sink for it. This might, also seem close to home when we think about animals and food waste. So turning that into biogas strategically to be inputs to chemical plants. And as Cindy was saying, also we're getting economic benefits from that and reducing costs. And if we look here, This is the UK. So they had a national program that started in 2005. It was voluntary, but the government did support it. I should say also that program in South Korea was government supported as well, but they actually stopped the government support in 2016 because it was going so well. They didn't need it. 13,000 companies participated. And when we think about Maine, we might think, well, gosh, you know, this waste is up here and this waste is down here. It might be hard. Yeah, transport is definitely going to be an issue. UK's almost 3 times the geographic size as Maine. So if they're able to facilitate all of these connections, I think we have a shot here too. So just in a couple of years' time, they diverted millions of tons of industrial waste, a lot of hazardous waste, lots of water use prevention, but it required, again, the trust and cooperation between these, because you have to be sure that the supply chain is going to be stable. You have to be sure that what you're getting is quality. It's not a typical transaction. So that's one thing that we're trying to build here, is getting the stakeholders to know each other and build that trust. And so in this case, just to say, there are some long distances here, but on average, it was about 20 miles. There's, yeah, high and lows to that range too. And I also just want to mention here at Maine, I'm part of a team and a company that started as a Department of Energy prize, where we're recognizing that in the next decade in Maine, we're going to have about 8,000 tons of wind turbine blades that are going to need to be disposed of or managed. And we don't want those ending up in the June Village landfill, which is already. So what can we do? Clever folks on my team at the Composite Center have figured out that we can take these blades and grind them down and compound them with recycled plastics and use that as a feedstock to make some of the really neat large scale 3D printing stuff we're doing. So I'm happy to talk more about the company, but I want to turn it over to John to give us a couple more cases.
I'll talk a little bit more about what's going on in Maine.
I should do this one.
Oh yeah, you can do this one too. Sorry.
Apologies. Hang tight. Sorry, team. Too soon. So, as we've been having conversations, we've learned that over in Oregon, they're also at the state level being proactive about this. So this is just in March, a bill was introduced to have the state economic development agency develop a plan to identify what are some voluntary industrial symbiosis opportunities in Oregon, what are the best practices, and what are barriers to adoption. And I thought something that was quite relevant to Maine is that they're actually working with seafood processors who are facing more stringent effluent requirements. So they're looking at working together at a port so that they can collaborate and actually create byproducts rather than creating pollution.
Yeah, this isn't Maine, but this is back in 2019, I was working with the Manufacturers Association of Maine on a project that was funded by the Maine Technology Institute called Waste to Wares. And so we were working with industry across the state of Maine to really figure out, you know, what is the need, what is the problem, and how many different materials and stuff could we repurpose within our own ecosystem. And we found that the Michigan Materials Marketplace was a really good example of a circular system that was in the process of being set up at that point. And it's then kind of turned into a project of basically a database system where companies can go in and say, this is the waste that I have. And another company can go in and say, okay, I need that waste and I will reuse that in my process. And so Reapply basically is a database system that is now used by many different organizations to put their information up and then try to find other uses for those materials as well. And so maybe a good model for what we want to do here in Maine. Allagash Brewing is a great example of a company that's very environmentally minded and looking at ways of trying to, you know, produce less waste as well. 98% of their brewery waste is kept out of the landfill. So they're working with farmers, they're working with recyclers, they're working with, different co-ops to try to make sure that all of the materials that they end up using within their process, and they are actually collecting materials from other groups within the brewing industry as well. So if you have, those caps that go on the top of 6-packs or 4-packs, they will actually collect all of those and either reuse them or recycle them and help people do that. So they bring those in. You can see a cork example here where they turn the cork into a different product, if they have enough of those. So a really good example of that. Another company we're working with actually right now just reached out to us, said, hey, we cut a lot of stone. And in that stone cutting process, they create a slurry. And I have samples, everybody likes samples. I'll pass these around. And what's really unique about these samples is it's almost like a non-Newtonian fluid. If anybody knows what that is, it's a very, if you push on it really hard, it's very hard. But then if you let it sit, it'll actually flow very slowly. But they are actively, they create 500 to 1,000 cubic yards of slurry annually, which is a lot of weight. I don't know if you can feel the weight of those containers. But that is basically just a stone dust that's mixed with water, and that is a byproduct of their cutting process. And they're looking for ways to reuse that material. Right now, it's just going into a quarry or going into a hole in the ground, and what it could be a value add product, especially for, say, the cement industry or other uses, even road construction and other things too as well. So is there an opportunity to reuse? Next one is Ready Seafood. They spend $100,000 annually to dispose of lobster shell. So we actually have a project going on right now on campus. Dr. David Navant and PhD candidate Greg Sims is working on repurposing that into lobster golf balls or other materials. I'll pass these around. So potentially a styrofoam replacement, potentially replacement for other materials. Think about a plant pot. So say if you have a lobster shell plant pot and you plant your seedlings in there, and then you can just put that into your garden, and your garden will be fertilized by that material, and your plants will just grow right through it once it disintegrates and gets reused into the soil. So looking at all of those different byproducts, what can they be turned into? Or who could end up reusing these? What kind of industries can we set up to actually do that? That, back to Cindy.
Okay, so so you've heard kind of the rationale, right, of why we're working on what we're working on. But you haven't heard it all. Part of the reason that we decided to work on this, we're actually many of us participated in the materials management task force that the state of Maine put forward to inform the latest climate action plan for the state. And one of the strategies that we recommended and was adopted by the Maine Climate Council was to investigate opportunities for industrial and regional materials exchanges. So this is now in state policy that we should be doing this for all of the reasons that we listed earlier, to improve our regional economics, improve our resilience. Also, as I mentioned earlier, to contribute to environmental justice, right? Right now, we oftentimes are disposing of materials in ways that are inequitable. So what are we going to do? So we have taken some inspiration from some of the other industrial symbiosis projects that Reed identified earlier. And really at this point, working on kind of the first step. And you can see from this project in Korea, it had to do with forming networks, gathering data, encouraging participation, getting stakeholder involvement, and trying to identify the best approach for going forward. So that's where we are now. So today actually is the first talk that this group is giving. We're just kind of kicking off the project. We'll soon be bringing a student on board as well. But there are really 4 components to what we plan to do over the next 2 years, the duration of the project. The bulk of the work has to do with having workshops. So we're going to be engaging stakeholders throughout the state in discussions about what opportunities exist, right? How could we work on this together? And we have some key partners, the Manufacturers Association of Maine, which, of course, lots of their members have all sorts of byproducts. The Maine Municipal Association and the Maine Resource Recovery Association, which is dedicated to really helping municipalities and folks throughout the state to manage materials in ways that are sustainable. So we'll be doing these workshops, bringing people together over the next 2 years. We're also going to be sending out a survey to try to start to understand what wastes are generated, what materials, and I should stop referring to them as wastes, right? What materials come out of industrial processes that could still have benefit and be much more preferable to use as inputs rather than waste to be sent to an incinerator or landfill. Our hope is to map those material flows over the next couple of years and produce things that might look like this map, right? Where we can start to see hotspots or clusters where certain materials group together. And then to work with our partners, not just these folks, but other folks who come on board as well, to create a collaborative proposal that would move us into the next stage so that we could scale this up and really operationalize it. So that is where we are now. And I think that is it. Yeah. So thank you, everyone. And
great. Everybody, wherever you are, whether you're in a room with a lot of people or by yourself, the first thing we should do is let's give a big hand to this wonderful group that just really helped us learn so much. So, and I see some people are doing it on the screen too. And that's really great. Just really great. We all learned so much. Maybe we think we already knew everything that we needed to know about how we set up a system like this, but I bet we didn't. And I bet everybody who's listening is now thinking, okay, how can I get involved? What can I do to learn this and be involved, to be a part of the workshops and the surveys and the mapping and the collaboration? So in terms of the speaker team, can you tell us a little bit about how all of us, if we want to follow you around and get involved and be some labor for you, how do we do that?
well, thanks, Linda. Yeah, we are absolutely happy to have folks involved. Absolutely. We do, I guess what we could do for now is invite people to get in contact. Our contact information was on that last slide, which will be posted up online. We are having our first workshop next week, actually, a week from today, at the Maine Resource Recovery Association meeting in Rockport at the Samoset. And folks are welcome to join us there, although we might be a little late for registration, but feel free to email and we can investigate that. We'll also be having workshops with MAME and with the Maine Municipal Association in the fall. So yeah, please do reach out, and we're happy to make this as inclusive as a process as we can. 100%.
You mentioned as you were all speaking about some very interesting industries in the state of Maine who are becoming partners or who have gotten involved, who are doing things like Allagash Brewing. If people are interested in learning more about who's involved and also sort of what we might do to learn from them and contribute to what they're doing, how do people do that?
Yeah.
Maybe we have to stay up.
Oh, sure. Okay. That makes sense.
We're coming first.
Yes.
So, so people can reach out to me, John Belding, at the Advanced Manufacturing Center. Just john.belding@maine.edu, and I'm happy to pass along and work, as a go-between between the organizations and us. And also the Manufacturers Association of Maine as well. They are a part of the project, and Mike Roughton, the executive director there, would be happy to answer any questions and help field questions as well.
Thank you very much.
Yeah, we're gonna be doing surveys but I'll say, if you are like, oh, I know a company and they have this, great, like let's get them proactively involved. So any thoughts you have on that? gosh, I've got a great use for this slurry, great, you know, it's gonna be kind of a formal process with a formal gathering of data.
And I guess the last thing I would say is for folks who maybe are not connected into the industrial system in Maine, but want to learn more about, you know, these types of things. There is a report from Waste to Wares, right?
There is.
Yeah,
Yep.
so maybe look at that work was not continued, unfortunately, and we're part of
Yeah.
this is an attempt to pick that back up.
Back up. Yeah, unfortunately, yeah, it was right around when COVID happened and everything got stopped.
And one person who's really enjoyed your wonderful talk says Ruth Reusable Resources has been doing this kind of thing for 31 years, taking manufactured cast-offs and making it available to teachers for classrooms. And Ruth Libby says she'd love to talk more on connecting with other companies. So do you have a strategy as if people who are listening today and learning today and want to follow up with you, what should they do?
Yeah, just please email us. And yes, we're very familiar with Ruth's Reusables. It's a great case study actually, and has provided a lot of benefit for teachers. And I just love some of their stories about deconstructing, you know, old 3-ring binders and repurposing them for teachers. They do really great work. So we would love to connect into all of the great work people doing reuse throughout the state, for sure.
So another question is, students show up, first-year students, at you know, a sort of orientation. And if we wanted all of our students to understand how important this is and the opportunities for them, how might any of us here help in terms of putting something together at orientation?
That's a good question. So there are, actually, Reed, do you want to say anything about your reusable? So there's opportunities on campus for people to use reusable things for food services on campus, for example. So you can use a tray basically that you can take to the union and use again and again. There's some stuff already going on campus that doesn't require much participation. So the kitchens in the commons have systems to compost the scraps that they have, not post-consumer, but prior to cooking. And otherwise on campus, I think on-campus housing has available opportunities to recycle that are maybe not as broad as we might like them to be. You know, what we can actually do in our area right now. And I think as with many things, lobbying and getting involved and thinking about how you can use less disposable materials. And you know, I see a lot of folks in the room today have their reusable water containers and coffee containers, and all of that is awesome, and you know, just doing the right stuff.
I mean, and Linda, to your point, I feel like for the students in the room, y'all probably have good ideas about how you can influence other students. So if you're part of student organizations, or if you're not yet part of student organizations, you know, that might be something that you can do. Like join one to think about what kind of activities could be useful for making folks aware. And yeah.
Maybe we
And
need
is
to
there
research learning experience.
Yeah,
Yeah.
RLE,
Yeah.
yeah, RLE would be a great opportunity.
Is there a chance that they could contact you and say, oh, I heard this great talk that you gave. I want to think about how, with my major, I and all my friends, that we could kind of think about what we could add to what we're learning. Who would they talk to from your perspective? Do you have any recommendations?
Yeah, and you know, obviously it would depend major by major, who would be the best person to contact. And so certainly we're open to being contacted, and we can point you in the direction of the folks that we know. we might not know everybody in, so yeah, that's a bit of a trick.
Hey, Linda, could I do a question from here?
You sure can.
Go ahead.
Thank you. My name is Harry. Great work there. I'm thinking from the consumer side of things. I see the focus is on industries, which is very good. But we know consumers have behavior and they would hardly change. Is your team considering possibilities of tackling the loosening up of the loop from the consumer side? Thank you.
You might take that one. Sure, yes, so on the consumer side, there are opportunities for reuse, which is probably the best way, and you know, buying things that last a long time, keeping them in good repair, taking advantage of opportunities like in Orono, there are opportunities to get stuff from a tool exchange or a tool library. And there's occasionally in Orono, there are repair cafes, which are great if you have something that's broken and you know, need somebody who can help you fix it. Then on those event days, you can go and do that. So those are great opportunities. Using the thrift stores, using consignment rather than buying things new. Those are all great things. And then upcycling yourself, being a crafter, doing that sort of stuff. It's all good. That actually, you know, keeps you looking fine and also, you know, enables you to not contribute to the waste side of things. And in many cases, actually keeps stuff out of the waste system. So that's one set.
Can I mention something related to that? That one of the questions was gatherings. If we're thinking about people gathering together, and there are a lot of quilt gathering groups and other kinds of groups like that in the state that come together, and they're reusing things. And is there a way that we could think as a university, drawing on your team, about how to bring these art people together with recycling and thinking about these kinds of things so that we're all learning and using the skills together? Thoughts about that?
Yeah, but I do want to go, yes, Linda, let me get to that for just a second, but I really want to go back to that last question for just a second. So I had a 5-year NSF project on reuse markets for like at the consumer level, right? What we call direct product reuse. Generated some really interesting findings. Key among them, when Jen participated in that work, key among them is that Maine, compared to other states, has a consistently strong and vibrant reuse market. Like it's already like culturally relevant here. So tons of opportunities in the state of Maine to foster and to encourage things like that, which is really exciting. But this project, I think, stands out in that when we look at the total waste stream, so what humans in the United States extract, process, use, and throw away, you know, it's difficult to get a sense of the total waste stream, but most people estimate that municipal solid waste, so what consumers and households throw out, is less than 30% of the total waste. Right, so we've got 70% associated with the materials production cycle, right? And so we really want to get to that. In terms of Linda, thank you for sorry to go back to that, but I just really wanted to hit that point.
No, that's great.
And but so Reed, you had an idea for how to answer Linda's?
Oh, I mean, so one thing that we're thinking of, we're planning to build out of this is a stakeholder network related to these material exchanges. So I think that could encompass a wide variety. We were remiss at the start of not thanking the Mitchell Center for the funding for this. So thank you folks for helping make this happen.
But I think I've got a question or two still here. Let's start.
Great.
Yeah, so my understanding is that there's a lot of companies who profit a lot off of very wasteful economy, cradle to grave, and they have lobbied against kind of a circular economy and for a wasteful economy. How do you fight against lobbying big companies pushing against the circular economy idea?
It's a really great question.
It is a good question.
I mean, I think part of it is through the type of science that Jean and Reed do that can give us objective environmental impact data, right? I mean, and also recognizing that even when some businesses do profit off of, linear models. Some of them also are advocating for the circular economy model. But life cycle analyses and other types of environmental impact analyses have actually shown that like, oh, wait a second, this ended up being worse, right? Because it produces toxins that get circulated in the system. So I think there are a lot of answers to that, right? Part of it has to do with political reform, but I think from our perspective as a research team, a really important part of that process is to actually objectively look at like what are the environmental impacts of these different processes and do they really make a difference, or is it just greenwashing or obstructionism, like corporate obstructionism? So
And I think at grassroots level as well, so getting, groups of companies within the state that aren't affected by the larger piece and making sure that they understand what it is and then see the benefits as well, and then trying to set up those relationships at the grassroots level.
Yeah, I got a couple more questions here. Go ahead.
You mentioned that in South Korea and United Kingdom, these projects are nationally funded. How's the case in Maine? Like, are there state funds or federal fund to foster such projects?
Yeah, that's a great question. And so I think in those programs, they were sort of treated like seed funding to, it's collective action takes effort, right? And so when that's recognized and when there's strategies, okay, recognize they're investing in this to make jobs, to make savings. And kickstarting this project was conversations with folks in Maine state government who are very interested in this. And we kind of realized that in order to make the case, we need to get the data first. So this is sort of our seed project to be able to gather up and say, look at the potential. I think there's some visionary ideas of, can we go to a town that's economically depressed in Maine and develop a campus, like an eco-industrial park here in Maine that's strategic like that? Or we can decide that that's not the strategic move, and what we really need is to facilitate these material exchanges across the state. But yeah, so I think it's going to be gather the data first, make the case for the funding, and be able to demonstrate, here's what we think the savings and benefits can be. Look to other cases in Oregon and elsewhere to be able to say, this is what they did, this was what they were able to accomplish.
I think I have one more question here.
Yeah, so thinking about like the future and moving forward, as students or young professionals, like what sort of workers or specialties or skills would be like really well suited for like getting engaged with this work and moving it forward?
Anybody with an interest.
Yeah.
There needs to be all types, so there needs to be the economic side, there needs to be the engineering side, there needs to be, research side. There's so many pieces to it, I think. Basically everything.
Yeah, communication will be
Yep.
really big. Like part of the problem in many cases is that people don't know what's available and, they know what they need and they know how to make their thing. They don't necessarily know how to make either their waste useful to someone else or how to make use of something that is coming from a different process. It's, all of the things.
Matchmaking, it's
Yeah.
it's all
planning.
planning.
Yeah.
Yep.
Economic
Economics.
analysis.
If I could pick up on something, I guess Cindy was saying as much as anybody, but it's part of your work. So you found that there's a strong culture of reuse from your prior work with Jen and with Berry and with students. It made me wonder, for the industrial side of this picture, is the social capital that might be a little unusually strong in Maine in that context? Does that either give you hope that on the industrial side, John, maybe you just have an intuitive sense of how strong these relationships are, what the trust is like? I just left a meeting where all people were talking about was if we just get the top technology right, and yet I think that it's often the case that if we don't have the relationships right, we don't get there. And I just wonder how you guys think about that.
I think in industry in Maine, there is a lot of strong relationships, and I see that as a very positive. A lot of groups working together. And so I think there is, in our DNA and as Mainers, there is that. Sometimes we like to go it alone, but other times I think we like to work together as well. And I think there's opportunities there. And we'll see that. Especially if, as everybody loves a bargain, right? So it's, if there's a good bargain, I mean, we have Rennies, we have, you know, Martins, we have all of these places that are kind of reusing right now, and it's, we do see that.
I don't want to brag, but I did buy 2 pairs of pants from Goodwill this weekend, so.
There you go.
Thank you.
I mean, the Waste to Wares project, if the pandemic had not happened, I think would have continued. There was 20 site visits that happened there and a lot of enthusiasm. There's an advisory board, there's a lot of engagement. So, I mean, when we contacted Maine about this, they instantly said, yes, we're so eager. So
Yep.
I think one thing we'll have to think about is communication. It's like we've got folks across the political spectrum. So, you know, you want to involve people to them.
And I think that it's clear there are a lot of different benefits, right? And so I think that in that list of like potential benefits with these types of exchanges, folks who have different interests can find something that's resonant, so.
And David, can I just add a couple of things?
You bet. Not a
Um,
many.
So people are saying in the where they're writing in comments are saying wonderful that this work is underway, and thank you to the team for spearheading it. And people are saying, keep me involved or involve me. I want to be a part of these initiatives. So you have a group of people who are leaving today excited about new information that they heard and linking to things that they already knew. And so what I hope all of us will do as we leave is think about 3 or 4 people tonight we want to tell about what we learned and what we're going to do and what questions were raised for us from the great work that this team is doing.
Thanks for that.
Thank you, guys.
Thank you.